Hello guys, and welcome to another one of these videos. Now, after some requests from you guys, uh, I'm going to remake the steering wheel I showed in my previous video, the one that I drove the bolt pattern on with the global parameters. Um, so let's start. Okay, we'll start on the ZX plane, and I want to make a circle of 25 millimeters. I want that to be at a distance of 350 divided by 2. And I want this to be horizontal to the origin. So my steering wheel is going to have a rim diameter of 25 millimeters, and its rim is section diameter. And its overall diameter is going to be 35 centimeters, right? Uh, so I want to have some finger bumps on the top. That's a good candidate for a loft. Um, but in order to do a loft, like a semicircular loft, you need a profile to start and one to end. So that means I need a second sketch with a circle, right? And I can just use the same dimensions as before, and that'll be good enough. Okay. So now I can loft from here to here. Of course, if I do that now, nothing is going to happen because lofts are used when you want to change the shape along the path, and they need to start and end somewhere. So I can't start here and end there because, what would that be? It wouldn't be a 3D shape. So now I need something to guide my loft and be semicircular. Okay, so let's sketch on the XZ plane now. And I'm going to bring both my sketches in as reference figures, right? So that I know where it starts and where it ends. And let's start with a 3-point arc. Okay, so that's the outside of the rim. Uh, let's ignore it. Let's see what we have up to this point. Okay, so I've got my two circles, and I have this line that touches the sketch of the profile. Now, I will be using local guides, and in order for them to work, they need to touch the actual profile. You can have a local guide that is floating in the middle of a profile somewhere. And I'll sketch on this plane again. And now, what I'm going to do is, oh, wait, I also need to project my two sketches again. So what I'm going to do is start from the center, now go into the inside of that uh, projected circle, all right? So we make that, and then we make a 3-point arc, and that, so this, I will be dimensioning this 25-degree angle is going to be to the center of that finger bump, right? And from that center, that finger bump is going to go on for 15 degrees, okay? And I also am going to select the midpoint constraint with 3 points. So first two define a linear segment, and the third one makes sure that it's always on the perpendicular bisector. So because the way this is designed, well, right, um, that means that every time I change this, it will change symmetrically to this line that defines the 25 degrees. So no matter how long I make the finger bump, the center of it is always going to be at 25 degrees. Okay. And I will also give it a radius of, well, I mean, 25 should be fine. Right. Okay, and now another 3-point arc, and that's Yeah, let's make its center coincident to the origin. So it's going to be concentric to this initial one. Let's make these 2 points horizontal. So now that's fully defined, right? And now, because this is going to be a guideline, I cannot create the loft and then fillet it, or at least I don't think it'll work very well. So because this is going to be a loft guide, I want to fillet while in here, and that's probably the only reason I would fillet in Sketch ever, right? Okay, that didn't go very well. And the reason that didn't go very well is because this coincident constraint broke, as well as the midpoint constraint. That also broke because the constraints are no longer there. So I'm going to delete this dimension, and I'm just going to say that these two are equal. Okay. Then I'm going to take these guidelines and stick them into these centers. Okay, again. And now remake that midpoint constraint, and we're good to go. Yeah, the horizontal also broke. Okay, now I want to make a mirror line, and I want to mirror all of these things. Okay, I want to mirror these things. Oh, sorry, I don't want to mirror that. Right, I want to mirror everything else along this axis. Okay, and we're good to go. And I even made this one better than I did the original one, right? So what do you think? Is that pronounced enough? I don't like it, so let me change that. Okay, and by me changing it, you'll also see how it works parametrically. So I'll make this 17.5 degrees. I'll make that 20 millimeters, right? 18 millimeters. Okay, so shorter but more pronounced. And then I will make that 20 degrees. Yeah, that's too much. 17.5. You know what? I'm just going to leave it like that. By the way, because I have mirrored it, all of these symmetric constraints mean that this side changes as well. Okay. So now what I'm going to do, right, is I'm going to loft. I'm going to select my two profiles, and I'm going to the guide. I'm going to go into the guide options and select local guides. Okay. So I select this guide. Okay. And then as a second one, I'll select this guide. Okay. Now what does that do? Well, the shape changes to follow the guide that's closer to it. So the inside part, when this inside guide comes more to the center, it becomes more of an ellipse. Okay, whereas the outside of the shape is not affected, and that creates a very nice little top of the steering wheel. Okay, now I want to create the bottom of it, so I will just go into the ZX plane, project my sketch one. Right. I want to project sketch one, but I want it as a reference figure, and I want to maintain association, right? That's important. And I'll take a 3-point arc. I'll make sure that's there, and that's horizontal. Okay. And look what I can do now. The bottom does not need the profile to change. So if we don't need the profile to change, we don't use a loft, right? So I'm just going to use a sweep. But to use the sweep, I need a profile to sweep. So I'm just going to project that one, and it's taken it in already. And I'm going to, there you go. Okay, so that is the rim of that wheel. You know what? I still don't like, yeah, I still don't like that. So I'll take this 20 and this 10, I'll make it 20. All right. And then I can open this up a bit. That will look better, I think. Yeah, more acceptable. Okay, so now I want to make the center, right, the hub of the steering wheel. And since this is a rally-inspired steering wheel, it's going to be a dish one. So I want to make it, I want to give it an offset of 75 millimeters. Okay, so I will design the hub down here. And I think the numbers went, was nice the way it was done in the other video. So 120 and 60. Come on. Oh, my mouse doesn't want to cooperate. Oh, no, 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 no. You don't need to project anything. So I touched this, and because I was in a dimension, it projected everything automatically. Okay. So let's say that this is 8 millimeters thick. So now we want to make the arms, right? And come in here, right? I will project this as a reference line, and I'm going to create a sketch. So I'm starting the sketch from inside the material to make sure that I don't get any part of it, I wanted the arm to go fully into the material of the hub so that it presents one uh, continuous unit. If I had started my profile from here, it would be tangent and would be flying off. Of course, I could have used the remove face then and fix that, but this, I think this is a bit better. So I'll give it 10 millimeters, 12. I'll give it 12 millimeters to go in. So this flat part is going to be, yeah, 17.5. And then what I want to do is I want to project this as a reference. Okay. Let me reset my view. Okay. Now, what's the problem here? If my arm is going to go dead center into the rim, I need to, and if I do it like that, right? Look, I will be starting my path from the bottom of my profile, and I will be ending it at the center. So the profile is going to stick from the center and onwards, and I don't want that. And I'll give you another tip for Alibre. This is now coincident, it's not moving. If you want to break a coincident constraint, what you do is you hold Control, you click and hold the point that you want to break the coincident, and you move it away. And the coincident is now broken. Okay? So the way I'm going to fix that is I will also project this top surface. I will get a reference line between the two, and then I'll get a reference line between the end of the path and this center. Now I want to say that this reference line is perpendicular to the path. Okay, and then I want to make it equal to this. Okay, so now, is that right, by the way? This needs to be half that length. So I will break that equal constraint. I will dimension this and take that. I don't even need to. I have that value. Okay, so I will just make this. I'll create a dimension here. I will go into my equation editor, find the thickness from extrusion 4, and say that is not that much, it's half that. So we're full constraint now. Okay. That is the path of our arm. Now I want to create a plane along path at 0. That's fine. I'm going to design my profile here. So this is a rectangle. The center of the bottom line is at the origin. This is collinear to that, and now I just need to dimension it. Let's say 75. Yeah, 75 is fine. Okay. Now, if I sweep this, right, what I get is a continuous thickness arm, and I don't want that. I want this to be thinner as it reaches the rim. If I use a draft angle here, the problem is, yeah, inwards. The problem is that it drafts also the thickness, okay? So that's why I cannot use a sweep here. I do need to use a loft. But in order to use a loft, I will face the same problem I faced in the other video. I know I will, which is this acute transition creates a self-intersecting shape, and it's not going to work, right? It's not going to work, so I need to fillet this a bit, and 15 millimeters should be fine. Alibre is clever enough to keep everything fully defined, even though I created a fillet here. So we're good to go. Okay, and so I will create another plane along path at the end of this whole thing now, and I will sketch on it, and I will say that this is D11, right? It's that thick. This point is the middle of the bottom line, and we started with 75 on the bottom profile. Let's make it 40 here, right? Let's make it thin at the end. And now, look what I can do. I can loft again. Okay, I can start from this, no, I can start from this sketch up to that sketch. Okay, but now I want a center line, and I want this to be the center line. Okay, and even though it's not that center, it still acknowledges it as a center line. Okay, look, it happened even now. So I'll show you two ways to correct that. Okay, so this is our first arm. Okay, this is flying out a bit, so one way to correct it is to remove face, right? You see, it heals it beautifully. Actually, remove face works very well in situations like that. Of course, another way you could have done that is if you went into that loft and made this profile slightly thinner. Okay. Now the remove face throws out an error because there's nothing to remove, but in actual fact, I kind of liked the way it was before, so I'm going to leave it like this. Okay. Ah, yes. Yeah, small fact. If I remember correctly, you cannot mirror a remove face. Yes. So if you want to remove face, you need to mirror this loft, and we're mirroring about this face, and then remove face in both locations. And it's failing now. Well, remove face is a bit finicky, so I'll just go ahead and bring that down to 70. Remove face is a direct editing feature. It's attempting to bridge um, parametric and direct editing software. It's a bit weird. Okay. Now, if you look at this, you will see that these finger bumps are too close to the arm, and there's no way that you can actually drive the steering wheel like that. So let's go into our first loft. It was sketch 4. Everything is still parametric, right? So I can still bring this up a bit and regenerate all. This looks a lot better. And now if I hide my planes with Alt 3, I can, oh yeah, again, I'll hide my sketches as well with Control Shift K, and I'll select this surface and hit H for holes, and I'll open the hole wizard. And let me see if I remember correctly. The M5, I should have saved the preset. So that's 11.6, the diameter of the top chamfer. 90 degrees is fine, and 5.5 is the clearance hole, of course. Let's take that through all. I think that's the correct. I think that's the correct dimensions. Remove the remove face. Now, um, in order to fully define it, I need to go back into the sketch because when you're using the home wizard, you don't get all of the sketch tools. So now I'm just going to make a circle. Okay, I'll make this circle a reference figure. Me having hotkeyed the make reference, right? Make a figure into a reference figure. Having hotkeyed that, I find it's quicker to design the normal ones and then convert them to reference. Okay. Okay, so and we need that to be a diameter of 90. Okay, so that's good enough. And now that we have fully defined this, I will make a circular pattern out of it. I need 6 of these, and the center is that. Okay, and if I want to make it even more beautiful, I would, open this drop-down menu, face color. Let's make it a bit darker this time. Okay, select these two faces. Let's see that it's leather, so it'll have some reflectivity. 20% is fine. 21, whatever. Let's apply. Okay, and that's how you make that steering wheel. I hope you liked it. I hope you find that enjoyable, and I hope you make one of these for yourself. It'll be fun to have a design like that, and you do learn a bit. We had two different types of loft. We had a loft with local guides, and we had a loft with center line. Then we did a sweep. So yeah, interesting little part. I hope you liked it. If you did, hit the like button, subscribe. Uh, if you didn't like it, hit the dislike button. If you have any questions, send me your questions in the comments, and I hope I'll see you in the next one.